Hi, welcome back to another video. So in this video, we're going to be doing the setup of this recent 5-inch build we did. So this is the second in a little mini series. If you didn't see the full build, it's quite a long video, but there are chapters through it. I'll leave that link above, and that's where we build this Apex Evo on 04. So yeah, really happy with this. At the end of the last video, we plugged in the smoke stopper just to test it. Everything seemed okay. So in today's video, we're going to be going through the full setup. So that's going to be updating the flight controller, configuring the receiver, our mode switches, putting GPS on it because we do have a GPS on there. And then hopefully at the end of the video, we'll get it up for a hover, make sure everything works. And then in a follow-up video, we'll get it out on our test flights. So first things first, we're going to connect it up to Betaflight. And that's just the USB-C socket on the side. And straight away, we get some errors when we plugged it in because nothing's been set up. This is a blank flight controller. We're going to update it to the latest version of Betaflight. Makes sense. What I would say is, if you're watching this video and you've got another build and you've been looking for some tips and things, don't update your firmware if you don't know what you're doing, because you're going to lose your existing tune. So whatever your drone, if you've got a bind and fly, leave it as is. We're only changing it because it's a new flight controller, so we might as well start from the newest. So I've downloaded Betaflight from app.betaflight.com, and then we're going to click on the top right hand side, update firmware. And the reason we do this is when we click detect, it'll tell us what board we're running. So this is coming up with a T-Motor F7. And for eagle-eyed viewers, if you watch the first video, you'll know that we've not got a T-Motor flight stack. We've actually got a T-Motor ESC and we've got a Meps flight controller. But Meps and T-Motor, they're kind of like sister companies and they're made in the same factory. So the Meps is a T-Motor, it's just branded under Meps. So they're really good quality. If you're on Windows, you should just be able to carry on an update from here. It's a little bit funky on Mac. So what I'm going to do is remember that was T-Motor F7. Going to connect back to the drone. I'm going to go into the CLI and I'm just going to put it in bootloader mode by typing BL. We'll click on update firmware. We get back to the same point, but if you notice, we now can't detect the board. So we've got to remember what it was, and that was T-Motor F7. Select Betaflight, we're going to go with the most recent version. As of today, that's 2025-12.2. That's everything fine on that side. A few little things to change on the right. Radio protocol, we're running ELRS, so that's going to be Crossfire. OSD protocol, we'll just put it on digital. We're running D-Shot, that's fine. And we've got some additional options. Now, I'm not using Acro Trainer. I have no idea what optical flow is, and I don't know what rangefinder is. And VTX, that's for analog, and we're running digital, so we don't need that either. Now, because we have got GPS, we may as well add the additional options just in case we want to use them at a later stage, and that's going to be altitude hold, and it's going to be position hold. Now, you've got an option of turning on magnetometer if your GPS has one. Mine doesn't, it's only a little baby one. We're probably not going to set up the position hold and things like that, but we'll put it onto the board, so if we want to do it at a later stage, we don't have to reflash. Everything's done. We're going to click load firmware online and then flash firmware. Now, if you hadn't have gone into bootloader mode like me, when you click that, it's going to prompt you to save your configuration. So obviously do that so you've got a backup just in case. Okay, so that seems to have done. So now we'll click connect to come back to the drone, and it's just going to warn us we need to calibrate the accelerometer, which we'll do next. So what you need to do is make sure your drone's on a nice flat surface, nice and level, and then click calibrate. Ours was pretty level anyway, and that just calibrates the gyro. And if we look on the top left-hand side, we can see it has updated the firmware. So we're going to go through these options, not necessarily the right order on here, and I will leave timestamps if you want to flip around the video, but we're going to start by going into our ports tab, because we need to tell the flight controller where the GPS is and where we've installed the ELRS antenna to as well. Now, I know for this board, UART1 is reserved for the DJI 04, which we plugged in. So we're just going to turn on configuration MSP. Now for the receiver, we soldered ours to TX2 and RX2. So that means UART2 on the flight controller. So for UART2, we're going to turn on serial RX. And then in another page, we'll tell it what that is. And last but not least, we've got GPS. I remember that we put it on UART4. So for GPS, on the center input, we're going to turn on GPS. Now, when we click save and reboot, things will configure and the GPS will start to kick in. So what we'll do now, let's click save and reboot. The next thing we're going to do is just nip down to receiver. So what it should say on the top right is serial via UART, and the serial receiver provider is Crossfire because we've got ELRS. If you were running something else like the DJI controller, that would be S-Bus. It'd be a little bit of a different setup. So at this stage, you would normally set up your receiver. So for me, this receiver is already on ELRS 4.0, and I know it's already bound to this radio. So if I turn this radio on, so what I'll do, I'll just remove the power and power back up. There we go, telemetry connected. So you can see that's already set up on there. So the next thing we're going to do is we're going to move to the configuration tab. A few little things we can change on here. You can obviously put your name. I like to put the aircraft name just because it's in my OSD, so remember what it is. Then we've got the arming angle. Now you should always change this to 180. If you leave that on 25, it just means your drone's not going to be able to arm if it's more than 25 degrees angled. And obviously it could be upside down, it could be anywhere. So if we change this to 180, it means the drone in any orientation, you'll be able to rearm. Air mode, we're going to leave that permanently enabled. I normally turn that off on a cine whoop and put it on the switch, but on this, we don't need to do that. And on the right-hand side, we've got RX lost and RX set. We'll turn that on, and that just means if it loses the receiver, it will start beeping. Now we can click save and reboot. Now we're going to jump to the receiver tab, and let's see if the receiver's set up. Our throttle, our yaw, our pitch, and our roll all set up. So I have a standard Freestyle model on here. That's why you'll hear my radio has got call outs and things. So we'll get it configured for this drone. Now on here, if you haven't got your aux channel set up, if you go into your model and go into your mixes, it's on your mixes where you need to add your switches. If this is your first time setting up your controller, you've only probably got 4 on there, your pitch, roll, yaw, etc. And if you find your aux channels aren't moving when you flick the switches, then what you need to do, you need to click add and then flick the switch and it will add that as an aux channel. I've got mine in order, so I have it the same on all my drones. The next thing we're going to do is set up the motors. So if we go to the motors tab, you've got a couple of decisions to make here as well. On your drone, you can decide, do you want your props facing in or do you want them turning out? I'm going to fly props out. I don't notice the difference when I'm flying, whether it's in or out, but if your props are turning in, what it means is all the dust and dirt is going to be coming in towards your camera, which I don't want. If they're going out, the dirt and things are going to be flicking into your flight controller from the side. Some people argue that obviously if you clip something as well, props out keeps you away from it, whereas props in will suck you into it. So we're going to go props out. So if we look on the top left here, we've got motor direction is reversed. We're going to click that. And if you look at the arrows, we've got our props facing out. Let's just click save and reboot. And now we're going to have to reorder the motors. So because we've soldered them up, we need to tell the flight controller which one's motor 1, 2, 3, 4 and which way they're spinning. So we click reorder motors. It's at this stage, it's important, no propellers on your drone, and you are going to need to power them up as well. So no propellers on, it's nice and safe. We're going to add power to the drone. I understand the risks. Start. Now, if you can see this motor is spinning and it's asking you on Betaflight which one is spinning. So we've got the front of the drone, so it's this one. Next, we've got our top right, click that. Then we've got this one. And then we can see this one spinning as well. And we'll click save. Nice and easy. What we need to do now is make sure they're spinning the right way. We've got props out, so these should be turning out and these should be turning in. We've still left the battery on. I understand the risks. We're going to do them individually. I find it a little bit easier that way. So let's click on motor 1, which is this one. And carefully, you need to work out which way it's spinning. Now I can tell you it's spinning this way. I can see it, I can feel it with your fingers. So it's spinning this way, and if you look on the screen, that's correct, that's the way it should be. Motor 2 should be spinning out, and if we click that, that is spinning that way, so that one's correct. Then we've got motor 3, should be spinning this way. Right, now that's spinning the opposite way, so that's spinning this way. So what we'll do, we're going to click reverse, and do it again. And now it's spinning the right way, so now it's spinning this way. And we've got motor 4, so that should be facing out, and at the moment it's facing in. So again, we're going to reverse motor 4, and that's facing the right way, and we can click close. Underneath this, we've got our motor features. So this is an F7 flight controller, so we should be running that at D-Shot 600. You can run it at 300, but it will allow 600 on this flight controller. We've got bi-directional D-Shot. I always recommend turning this on, and it just enables you to use filtering, which we're going to need for the tune that we're going to put on it. And make sure your motor poles are correct. Now for a 5-inch drone, it is 14. I've checked them, it's easy to count them. If you've got a smaller drone, that may be a little bit different, so just check that. and we'll just click save and reboot. Now I'm just going to disconnect that for a second. This flight controller is also running AM32, so it's a 32-bit flight controller. Now it's my first experience with AM32. I've never had a drone that used this. So basically you just go to the website, search for AM32, and it'll load in Chrome, and then you can download that as a web app. So I've got that saved. We need to disconnect from Betaflight because it can only talk to one thing at once. Put the XT60 in, click connect and read. So I'm not really used to this layout, it's brand new. I've done a little bit of research before today's video. So we've got 4 boxes and these are green. If I click on them, they go grey. When they're green, it means we've picked all the ESCs. We're changing them all at the same time, so we want to make sure all 4 are selected. You can see the change we made before in Betaflight is replicated here. So you can see 2 of the motors are reversed. You could just make these changes on here, but it's always better to do it in Betaflight. Very small on there, but we can see the firmware version is 2.16. So let's have a look what the latest version is. So top right, we'll click flash firmware, and the latest is 2.20. So we'll do that and we'll select ESCs to flash. So we're going to pick all 4 ESCs and click start flash. While this is flashing, I'll just obviously remind you, make sure you use a charged battery as well. You don't want the battery running out midway through this process. It's just writing the last one now, and we're going to wait for the beep so we know it's done. Excellent. Now there's a few little things you can change in here, and I can see something straight away we do need to change. We are using D-Shot, so let's pick that on there, and it's just making sure that if there's any errors anywhere, it knows it should be looking for D-Shot. So we're going to leave these pretty much standard as they are, but what I do notice is the motor KV is wrong. It's saying 2220, and these are 2050. So let's change that to 2050, or as close as we've got it. 2060 will do. PWM frequency, it's works a little bit different on here. You set a range, so 24 to 48. That's what it's recommended for AM32. And I think everything else we just leave as it is. Once we've done that, at the top right hand side, we click save, and that is done. And now we can disconnect. So let's jump back onto Betaflight. And then we're going to go onto the modes tab. So this is where we set up our switches. So first of all, we need to set arm. Now I have that on this switch here. So all you need to do, you click add range. Automatically, it's set to auto. So whatever switch you move, it's going to set that. So if you notice at the bottom, it's on 1000. And when it's armed, it's on 2000. So we need to move this to cover the 2000. Now I don't really use angle mode, but we're going to put angle mode on a switch. So we're going to set that here. Next, we want flip over after crash. I have that on the same button at the top. That's GPS rescue, all the way to the top. Then we've got our beeper. So again, add range, that can go on this back switch. And that's it. So when we hold that switch, that'll turn that on. So we'll click save. The next thing I'm going to do on the adjustments tab, a lot of people don't use this. I use this all the time. On here, I like to be able to select different rates. So maybe I've got different rates for different scenarios, or maybe I want to try a few different rates when I'm out in the field. So you can set those easily on a switch. So all we need to do, we need to turn it on, enabled. We need to select our OGS channel. So to do that, we can see it's OGS 3 there. So I'll go to the adjustments, it's OGS 3, and you set it exactly the same at the end as well. Then in the then apply is going to be rate profile selection. And all we're going to do, just colour it all in. So if you colour all that in there, go to the PID tab, and we can see rate profiles. If you see on my switch, rate profile 2 and rate profile 3. So what we could do in here, because we're in the rates, we can actually set our rates as well. Again, these are very personal. It's up to you what you want to fly. For a 5-inch drone, I tend to fly my sensitivity on about 50. I find this quite smooth. Max rate, we'll leave that as is. I think I have that a little bit lower, so 600. And I like quite a bit of expo, just so I find it's not twitchy. We're going to call that default rates. We can set another rate. So again, I need to flick it on my switch. Rate profile 2. We can do the same again. So we'll put this exactly the same. Now on this one, let's up the rates. So let's put it to 800, and we'll put that to about 650. I always like it a little bit lower. And again, we'll put the same expo on, but we could change that if we wanted to. And we can call that 800. So if we're out in the field, again, once your drone's not powered on, you can easily have the 800 or go back to our default rates, and you can set up 3 on there as well. The next thing we're going to do, quite important, we're going to put a preset on the drone. So at the moment, this is running just default Betaflight. There's no tune on here. It's just whatever Betaflight set up. There's no filters or anything like this. Now, what I love on my 03 version of this, I fly the Superfly version, and it's fantastic. You can see it on here. We're on the right firmware version, and we've got Superfly Freestyle 5-inch. So we click on this, and we've got different options. I'm going to put no action camera for now. I will use one once I've 3D printed a mount, but we'll say none for now. Is it a clean build for high performance or average build? I don't like the word average, so we're going to go clean build. Let's see what happens. Radio link setup. So we're on ELRS, and we'll go ELRS 250. That's normally what I fly out for freestyle. You can go to 500 if you like. And we need to say what UART our receiver's on, and it's on UART 2. Don't just click pick and apply it. What you need to do, if you look at this here, click here to finish the setup. So we'll click this. It'll take us to a website. This is a real key part of this tune. And what you can do, you can customize it for your drone, and it'll tell you what to set your master multiplier at. So prop size is 5-inch. The weight, I don't even think we've weighed this drone yet. So let's quickly do the weight of this drone. So obviously we've got the USB plugged in at the moment. So let's reset that. Now this is the takeoff weight. So the weight now is 442. We've obviously got our little bolts. We've got our props. So we're going to have to count the weight of those as well. Bang all them on there. So 457. And battery. I have loads of these iFlight full send batteries. 1400 mAh, so probably around that. And we're looking at 687 grams. So if we look on here, we've got the weight, and we've got 650 to 700. That's us. We're running on 6S. Motor KV, we said that before, is 2050 KV on these. Motor output limit, no. ESC AM32. And there we go. Our master multiplier is 1.05. So let's just remember that. And then if we come back to Betaflight, we'll click pick, save and reboot, connect back to the flight controller. Now let's go into PID tuning, and we can see that these values have now adjusted. Now it did say our master multiplier on 1.05. So we'll just pull it down one. There we go, 1.05, and we'll click save. Now we're going to have a look at GPS. Obviously, you're not going to see all this screen. I'm going to block out where I live. But if we just connect this up, need a LiPo battery on this one. Depending on your drone and settings, sometimes it gives enough power to the GPS, but for some reason these pads don't give it enough power, so it won't do that. And the GPS should kick in. So on the top right hand side, you can see GPS. And the image that you're not going to see is an image of where I live. You know, we're locking loads of satellites in now. And this is from this tiny GPS. And we're in my office. I've got lights. I've got everything going on above, inside. And it's still picking up a network, which is great. So what we need to change on here, at the top, we want to be on U-blocks. That's the best. We want to use Galileo, just some additional satellites if we can. And the important one, set home point once. Because otherwise, if you crash and you rearm your drone, it's gonna change the home point. So we want to set it once when you first plug in and leave it at that until you change the battery. Ground assistant type, we don't really need that. We'll just put auto detect and click save and reboot. Because we've set up GPS, one of the last settings now, fail safe before we do the OSD. So one of the key things about this, you really need to get these dialed in so your GPS is going to return home safely. And to do that properly, we need to know our throttle hover point for the drone. We don't know that yet, so what I'll do in the next video, we'll come back and adjust this, but we'll just set some temporary values for now. But when we hover, we'll have our throttle in our goggles, we'll see what the hover percentage is, so we've got it, and we'll dial those numbers in here. Very important, make sure it comes home. Some of the key things are, at the moment it's set to drop, we want it to GPS rescue. So we're going to turn that on the right hand side. And you've got a couple of different options. You've got maximum altitude, so whatever the altitude was on that particular flight, it'll go to that. Or you can say fixed altitude, so come back like a DJI drone, go to 60 meters and come back. Or current altitude, so wherever the drone fail safes, could be low, could be high, it'll come back at current altitude. You really need to decide what you want, and you might want to change it depending on your flight. Why would you use different ones? I usually set it on maximum altitude, so whatever the altitude was on that flight. However, if you were flying up a mountain or down a mountain, you know, you're flying up there and you're flying all the way down and it fail safes, it's going to try and go up to that altitude that you started at. So that could be a problem. The same with fixed altitude. You know, again, if you're flying up somewhere and you're climbing up a hill and you set the altitude to 50 and you're now at 300, it's going to plummet and try and get down to that 50 meters. So just be careful. I'm going to put it on maximum. That works for me. Initial climb, 10 meters. If it fail safes, that's fine. I'm going to leave a lot of these at default. You can change how fast it comes back, but we'll just see how it flies. The key thing here is throttle hover, and that's the percentage that it hovers at. It's at 1275, which is obviously like 25% roughly. If you hover, probably about right, but that's what we'll have to come back and change. And the two important things below, minimum satellites, I'm going to drop that to 6. So as long as you've got more than 6, GPS rescue will work. Obviously, the more satellites, the more accurate it will be. And allow arming without fix. I'm going to turn that on. And it's very important to understand how this works. Most of the time, I'm not going to use GPS, so I'm going to plug the drone in and I just want to take off. No problem at all. So I don't really care about the number of satellites. Other times, if I know that I'm probably going to need it, I'm going to wait to get that minimum count, or 8, 10, something like that, and take off. If you take off with less than the minimum number of satellites, so if I take off with 5, even if it picks up more satellites on that flight, it is not going to return to home. It has to have that minimum before you take off, so just be aware. The other thing we need to do, when the drone fail-safes, what do we want to happen? It could be upside down, it could be, you know, all out of shape. So what we want to do, we want to put the drone into angle mode. So automatically, we want the drone, if it's upside down, the first thing it's to do is to put it in angle mode, which will make it level. If you come down to where you can see angle, and that means on aux2, we've got it in the middle position on our switch, we want to set the value to 1500, because angle's in the middle. If angle we had as our very, you know, at the bottom of the stick, we would set that to 1000. So for me, when it fail safes, it's going to flick that switch in software to 1500, which is in angle. And I'm going to set a throttle as well. And I'm going to set this to a little bit more than whatever your hover is. So our hover was 1275. I'm going to set that to 1400. So what that's going to do, in the event of a failsafe, my drone's going to correct itself. It's going to set the throttle to 1400. Now, hover's 1275, but it could be dropping the drone, so it's just going to give it a little pump in the air, just for a split second until GPS rescue clicks in. Save and reboot, forget about it. That's all we need. You set this up, decide what you have on your screen. I have a particular layout that I use, so I'm going to use that now. I've just copied it from another drone, and I can paste it in the CLI and click save. And that should set most of it up for us. We might want to tweak it. So if I go back to the OSD, there we go. I've got most things set up. So I've got my modes, I've got my return to home, I've got my angle switch, I've got the name of the drone, I've got my throttle hover, which is good, speed, altitude. Yeah, I think I've got everything that I need on there. Crosshairs in the middle, let's get rid of that. We do not want that. The other options you've got is after your flight, you can decide what statistics you want to show in your goggles. I usually change this because, especially doing reviews, it's nice to know how far you've traveled, things like that. So we'll get our altitude maximum, maybe our average throttle to see what we're using. We don't need the black box. I'm not bothered about the black box. Link quality minimum error, and let's just turn these on as well. So quite a lot of statistics, but we can see that in the goggles after we land. So that's your drone set up. I just want to change one little setting on the CLI, and this is personal preference, and that is just your average cell voltage. So at the end of your flight, you get the stats and it might say, oh, you're at 19 volts or 21 volts. It means nothing to me. I like going off the average cell. And to do that, where it'll say, you know, you're at 3.5 or 3.2, something like that, you need to change that in the CLI. To do that, if we type in set, it's report cell voltage. And we just press equals and on. So that's going to give us the cell voltage rather than the whole pack. The other thing I like to do is just to tell the flight controller that we're going to be using 6-cell batteries. Sometimes if you put a pack on and it's not fully charged, or you know it's a high voltage pack, sometimes it doesn't recognize it right. So I like to always force that, and that's going to be 6 because it's a 6-cell drone. And we'll click save. And that is everything. So we can turn that off now. We can put our props on. Again, always make sure you put them on the right way. So ours is going to be props out, so we can see which way they're going to be facing. We're going to put them on the front, put them on the back. We've got our bolts, and let's take it out for its first little hover outside, and then in the next video, we'll take you on a proper flight. Let's give it a test. So all I've done, I've just put my little hood on top of it, or my little fin on top of it. I've got a batch on. I've obviously added the straps I didn't have on there before. What I've also just done, I've just moved the buzzer as well. I noticed the buzzer was a little bit in the way here, so I've just moved it to the front for now until we find a permanent solution. So this is going to be the moment of truth. First time actually trying to take off. So let's get this plugged in. There we go. Right, well, we know the drone flies, everything seems okay, there's no errors, so we're now ready to start doing our proper test flights. So that's going to be the end of this video. Hope you've enjoyed it. If you did, drop a like, drop a comment, and if you haven't watched that first build series, do go back and I'll tag it above. Otherwise, now go on to the next one and we'll go through some flights, test it, let's test the performance, see how it handles itself doing some freestyle, and we'll test the GPS as well. So I'll see you in the next video.